So let's start now with the second part of our presentation related to the key health applications of sensor fusion, or in another word, the application of sensor fusion in eHealth. eHealth can be thought as the intersection between medical informatics and public health, which is delivered through internet and related technologies. So you can see even from this definition that the specification of what is eHealth is quite broad and blurred. In some sense, we can, include in the eHealth field all the technologies related to ICT, so information communication technologies, that try to support, help, and improve the current medicine. So in this slide, you can see a probably non-exhaustive representation of the whole eHealth ecosystem. Basically, what are the main parts that compose eHealth? If we start from this point and we pass clockwise, we can see that telemedicine is the third term that we see here. Telemedicine, or telehealth, is the discipline, the domain of eHealth that study all the interaction between the clinician and the doctor, delivered through internet and online platform. So building all the infrastructure that allow really safe, efficient communication of the consultation between the expert, the health expert, and the patient. On the second point, we see, for example, clinical information system. So this point is how we can store in an efficient and safe way all the health-related data, all health-related records. Then we have, for example, how we can build an integrated network. So basically how we can make all this database, this information stored in different, for example, hospital, in different clinics, from different doctor, from different system, communicating, how we can build an efficient interface between all these parts. And this is, of course, is more related to information system like cloud system and shared database. So in the left part here, you can see the two main domains that are more related probably to the course here we are doing here, the sensor fusion for eHealth. So these two domains are mHealth and big data. With mHealth, we refer to the part of eHealth that deal with mobile devices. So mHealth is actually an abbreviation of mobile health. And what we study here is basically how to make all the devices, so smartphones, for example, sensors, actuators, make them communicating and functioning for the task that we have to solve. So the task is a proper clinical task, like, for example, health monitoring. So ML is another big term which is related to all this kind of technology. So how to make sensors, how to make them functioning, how to make them communicating. The big data instead is how we can use the data that we have produced by all these sensors in a really efficient way. So basically, all the information that we have catched, we have measured through our sensor, through our devices, what can we do at this point with this data? With the teleological targets of providing a health service, a clinical service. So sensor fusion for eHealth is basically kind of a discipline that stay here in this kind of intersection region between these two main domains of eHealth. So this is the reason why I wanted, to explain this slide, because I think it is really important to understand that eHealth is not only what we study in this course, but it's a really more wider and probably not so well-defined universe. And if you want more information about this, I really suggest this paper, which is really well written, and you can see this scheme explained in a more specific way. So we have learned now the taxonomy of eHealth. So I think that at this point, we have to go more in deep and see why we need sensor fusion for eHealth. I think that is absolutely important to define the main application from the beginning in order to have a sort of teleological perspective to what are the goals, what are the target of all the technology we have studied in the previous part in this specific domain. And I think that we can divide this application in three big macro areas. One is sport monitoring. All the application related to athletes monitoring, so people that do sport, do physical activity, which are not patient, basically speaking. Remote patient monitoring, so in this case, have the possibility to assess the health status of a person remotely. And with this, we have a lot of other sub-application we will deal with in the presentation. And the third main one, I think, is smart assisted living. So as we said previously in the presentation, deals with all the application, all the kind of technology that try to, assist people in their daily living, especially elder people. So now that we have understood what are the main areas of application of sensor fusion in a eHealth domain, in this slide I want to show you what are the main reasons why we need sensor fusion in eHealth. So if we approach the topic from an operative point of view, we can categorize all the issues, the tasks related to the information technology in eHealth in two main groups. One is state estimation and the other one is anomaly detection. So in this context, state estimation can be estimating the heart rate, the respiratory rate of a person, or can be, for example, estimating what is the level of the stress of that person. So we have a kind of state that can be estimated. Anomaly detection is not as simple as it seems, because it actually involves even some philosophical reasoning about what is an anomaly, what is not an anomaly. But for us, for example, a classical anomaly detection problem of eHealth is actually estimating if someone has a heart issues, or detecting heart attack, for example, and so on. So with this kind of issues that we want to solve, sensor fusion actually can be useful, particularly useful for three main reasons, actually. The first one is improving the accuracy. So I think that the example we have provided with the Kalman filter is particularly useful in this case. What we used in that context was using three different sensors, which are quite cheap sensors, are not very precise, and we fuse the information for all these three channels to have a kind of reliable estimation of the heart rate and the respiratory rate. So this is particularly useful in this in the eHealth domain, where the sensors are particularly cheap and has to be cheap in order to be scalable. But of course, this comes to the cost of a single accuracy of the sensor, which is not enough for the issues, for the task that we have usually to solve. So sensor fusion is fundamental in this case. The second one, which I think in some way is actually even more important, is have a consistent detection of the state. Just imagine, if we want to detect an anomalous state of the heart activity of a person, we can't have a reliable estimation of this state if we don't take into account what is the activity context. So if my heart rate is 120, this is absolutely normal if I am running. If I'm not running and lay on my bed and I have 120 BPM, it's not normal for sure. So we want the point here is that we need to fuse different sort of information to have a reliable estimation. And this is particularly true in chaotic environments such as the human body and the daily living, daily context environment. The third one, which is I think is a quite minor compared to the two one, is avoiding centralized structure. So this is more related to privacy concern, but with this kind of algorithm, we can implement on-device paradigm. And this means that we can we fuse all this information in the device, have a reliable contextualization on the device, and allow the user to not upload all the data, all the raw data to the server, which is located in another part of the world, but maintain everything inside the single device. And this is really important because here we are treating with health data, which is probably the most delicate personal data. So in order to provide you a really practical example of what does this mean in real life, I think that smartwatches are the best example of application of how sensor fusion can be used in the eHealth domain. Actually, smartwatches can be considered an ensemble of sensors. So we can have electrical sensors like the ECG, which are able to measure the electrical activity of our heart. We can have optical sensor like PPG or SpO2 that are able to detect the oxygenation of our blood. And we have also inertial sensor like accelerometer or gyroscope. And this is used, of course, to detect the activity of the person. So if we are running, how fast we are moving and so on. So I give you here on the bottom of the slide a kind of use case of sensor fusion for a basic anomaly detection algorithm. So with the first two sensors, the ECG and the SpO2, we can measure the heart parameters of our the heart parameter of our body actually. So we can measure, as I said, the heart rate. We can measure the oxygenation level of the blood. With the inertial sensor, we can detect the activity. We can fuse the two information to spot if we have heart anomalies. Actually, the topic here is absolutely more complicated than this, but this is the basic, This is how actually we can build an anomaly detection algorithm which is able to detect heart attack, for example. And this is possible with a sensor fusion approach. So I put this slide in order to convince you that what we are talking here is far from being mere technological speculation or mathematical speculation. Here we are talking about real-life application, and when I mean real life, I mean saving life. I don't want to state that this is still possible because the technology is not as mature as it should be, but here we have some good example that at least 3 people whose life have been saved by this kind of algorithm, and their smartwatch has been able to detect an anomaly in their heart activity, and the smartwatch launched an alarm, and they've been able to call the clinician, to call the emergency before actually the heart attack happened or the anomaly happened, and they are still alive. And I think that just these 3 articles are enough to justify all the work we are doing in the sensor fusion application and in this lecture as well.